Hi everyone. So this is the 17th lecture in IE 451 Engineering Economy. And today we are going to continue to solve end of chapter 5 problems. And here's the first problem that we are going to solve for today, which is problem 5-28. If I is 10%, compute the present value P for the following cash flow. Okay, let me redraw the cash flow diagram because it's not very clear from the screen. So this is the problem number 5-28. And at the end of 4th, 5th, 6th, and 7th, and so on, there is a uniform series, looks like. Okay. And you're going to use 10% of interest rate. And we want to find the equivalent present sum of P. Okay, that is the problem. So the given cash flow diagram presents an infinite analysis period, which is n equals plus positive infinite, right? So we have to use the concept of capitalized cost. So we know that for the analysis period is positive infinite, the capitalized cost P is equal to A over I, right? And if I set P prime here, let's say if I set P prime at the end of period 3, let's say this is P prime, and interest rate is 10%, right? So if I set P prime at the end of period 3, the capitalized cost P prime can be computed by P prime equals A over I, the same formula. And then the A value is given as B in this cash flow diagram. So B over the interest rate 10%, which is 0.01. Is that right? So basically this is, I'm sorry, this is going to be 0.1 because it's 10%. Is that right? Okay, yeah, because it's 10%, it's going to be 0.1. And this is same as 10B. Is that right? And then this P prime can be converted to the equivalent present sum of P. So here we have P equals the P prime, P given F 10% over 3 periods. And this vector value can be found from our text, page number 613. P given F over 3 periods is 0.7513. This vector value is 0.7513. Okay. So this is going to be 10b times 0.7513, and this is same as 7.51b. Okay. So here the present value P at the end of period 0 would be 7.51b. Okay. Okay. Next problem is problem number 5-7. A stone cutter assigned to carve the headstone for a well-known engineering economist began with the following design. He then started the equation as follows. P equals G times P given G, I over 6 periods. And then he realized he had made a mistake. The equation should have been like this. And the stone cutter does not want to discard the stone and start over. He asks you to help him with this problem. What one component interest vector can be added to make the equation correct? So what you need to do is fill in this part. Okay? Okay, so first of all, let me redraw this cash flow diagram. So we are working on problem number 5-7. And here we have at the end of period 0, there is a present sum of money P, and then starting from period 1, we have a arithmetic gradient series, looks like 2, 3, then 4, and then 5, 2G, 3G, 4G, and 5G. Okay, like this. And if you look at this cash flow diagram, the period by period change amount is G, right? There is a positive G, another G, another G, and another G here. So the given cash flow can be broken into two components. That's what we've done many times so far. One for the uniform series, another for arithmetic gradient series, right? So here you have hold on a second. So here we have okay. So we have 0, 1, 2, 3, 4, and 5. 0, 1, 2, 3, 4, and 5. So if you take out G, then you have uniform series of G. A equals G. And then what is left over? At the end of period G, at the end of period 2, there is 1G, and then 2G, 3G, and 4G, right? So this is the arithmetic gradient series of G equals G, right? So let's say the present sum of money for this uniform series is equal to P prime and then this present sum is equal to P double prime. Then this P can be computed by summation of P prime and P double prime, right? So we have P equals P prime plus P double prime. So in this case, this is G times P given A and I% over 5 periods. And how would you get P double prime here? G times A given G I% over 5 periods. Okay? Sorry, this is going to be P given G. P given A, P given G. Okay, so obviously what we've done here is exactly the same as this, right? I just switched over the sequence of this each term. So G times P given A, I over 5 periods is right here. G times P given G, I% over 5 periods, right? However, the problem is the stonecutter started the equation like this instead of this, right? And the equation by stonecutter placed the present value P in period -1, actually, instead of period 0. So let's say this is P sub -1. Okay? You remember in the arithmetic gradient series, the first period has 0 cash flow, and the first non-zero cash flow occurs at the end of period 2. So if he want to use this formula, this equation, the p-value should be located at the end of period -1 instead of 0. Okay? So what you need to do is to compute the present sum at the end of period -1 and then move it forward 1 year using the single payment compound amount factor. So let's do this. So here, how'd you get P present value at the end of period -1? Simply, you can use this formula, right? G times P given G, I% over 6 period, -1 through 5 is 6 period, okay? And then move this present value at the end of -1 to the present value at the end of time period 0, okay? Using the single payment compound amount factor. So it's going to be P sub -1 times F given P I% over 1 period. Okay? Of course, you can combine these two procedures so that what you're going to have is P sub -1 equals G times PG, P given G, I% over 6 period, and then write down this. Okay? So F given P, I% over 1 period. Okay? And if you compare these two formula, you will notice that you just need to fill in this part with this. Okay? Okay. So the next problem that you are going to solve is, okay, what is that? Okay, next problem is, what about problem number 5-9? So the annual income from a rented house is $12,000, and the annual expenses are $3,000. If the house can be sold for $145,000 at the end of 10 years, how much could you afford to pay for it right now? If you considered 18% to be a suitable interest rate. So we are working on problem 5-9. Little bit modification of problem 5-9. You will notice that those numerical values are slightly different from the original problem. Okay? So that's why I put M stands for the modification of original problem. So here you want to know how much you could afford to pay for it right now. So you want to know the present sum of money. Okay? And starting from period 1, 2, 3 up to 10 periods, right? You're going to have a uniform series, looks like. Of how much? So it looks like each year you have a profit of $9,000. How did you get $9,000 here? Here, $12,000 of income minus $3,000 of expenses each year, right? So 12,000 minus 3,000. That becomes the $9,000. Okay. And what else? There is one more thing you need to consider. If the house can be sold for $145,000 at the end of 10 years. So at the end of period 10, you're going to expect huge amount of expenses. No, huge amount of benefits for you, right? Which is $145,000. And the interest rate that we are going to use is 18%. So how do you get this p-value, present sum of money? That's going to be the summation of uniform series of $9,000 over 10 periods. So 9,000 times P given A, 18% over 10 periods. And also you need to convert this future sum of money to the equivalent present sum of money P, right? So 145,000 times P given F, 18% over 10 years, 10 periods. Okay? So we need to look for 18%. So in our text, page number 616, P given A over 10 periods is 4.494. Okay? And what about this? P given F, 18% over 10 periods is 0.1911. So how much is this? Okay, this is going to be $68,155.50. So that is the answer for problem 5-9, the little bit modification of problem 5-9. Okay. Okay, here's next problem. Problem number 5-10. Consider the following cash flow. At a 6% interest rate, what is the value of P at the end of year 1 here, right? That is equivalent to the benefits at the end of years 2 through 7. Okay. So this problem looks pretty straightforward. So if you look at the cash flow table, the period by period changes. That's how much? Starting from years 2 through 7, every period there is a positive 100, right? So the period by period change amount is 100. So looks like we can use the concept of arithmetic gradient series, right? So let me draw the cash flow diagram first based on this cash flow table. So this is the problem number 5-10. We want to know the present sum of P. Okay, it's at the end of period 1 instead of 0. And then 2, 3, 4, 5, 6, and 7. 100, 200, 300, 400, 500, and then 600, like this, okay? So this cash flow diagram can be broken into two components. One for the uniform series and another for arithmetic gradient series. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. Okay? So if you take out 100 from each period, you will have a uniform series of $100, right? And let's set the present sum equal to P prime at the end of period 1. And for the arithmetic gradient series, here you have 100 at the end of period 3, and then 200 at the end of period 4, and 300, 400, and then 500, right? So this is the arithmetic gradient series with G equals 100, right? And here, the present value at the end of period 1 from the original cash flow diagram can be obtained by summation of P sub 1 and P sub 2. I'm sorry, P prime and P double prime. So this is pretty easy to do. P prime can be obtained by 100 times P given A, and then 6% interest rate over 6 periods, right? And then 100 times P given G, 6% over 6 periods, because it's from period 1 to 7. Okay. So let's get these vector values. 6% is shown in our text, page number 609. So P given A over 6 periods is 4.917. And P given G over 6 periods is 11.459. Okay? So how much is this? Okay, it's going to be $1,637.60. Okay, that is the answer for problem 5-10. And here's an alternative approach for alternative way for problem 5-10. So let me redraw the cash flow diagram based on this cash flow table. One, two, three, 4, 5, 6, and 7 here. And then we want to know the present sum of money at the end of period 1, right? And then at the end of period 2, there is a positive cash flow of 100. At the end of period 3, 200. Period 4, 300. Period 5, 400, period 6, 500, and then at the end of period 7, 600, right? So what you can do here is just like the problem 5-7. First, you may place the present value, P, in periods 0. Let's say 0 down here instead of periods 1. Okay, so let's add here we have P sub 0. Okay, so once you get this P sub 0 using the arithmetic gradient series, then you can move this P sub 0 forward 1 period. Okay, so how would you get P sub 0? That's going to be 100 times P given G, 6% over 7 periods from 0 to 7, right? And once you get P sub 0, you can convert it to the equivalent future sum, which is P, right? So P can be obtained by P sub 0 times P given, F given P, 6% over 1 period, okay? Of course, if you want to combine these two procedures, then P is equal to $100 times P given G, 6% over 7 periods times F given P, 6% over 1 period, right? So let's get these factor values. So we are looking at 6%. P given G over 7 periods is 15.45. So 15.45. And what about this? F given P over 1 period, 1.060. Okay. So how much is this? It's got to be very close to $1,637.60 that we've got from the first method. Okay. So how much is this? Okay. Actually, what I've got here is slightly different from the previous one. I guess is 10 cents difference. Okay. So right now I have $1,637.70 instead of 60 cents. Okay. Okay. Here's the problem number 5-12. A manufacturer is considering purchasing equipment which will have the following financial effects. So for the next 4 different periods, there is a disbursements and the receipts. Okay. So obviously the disbursements is the negative cash flow and the receipts is the positive cash flow. If money is worth 6%, should he invest in the equipment? So for each year, if I add one more column called cash flow, then this is going to be negative 4,400, right? And then 880 minus 660, which becomes 220. Okay, and 1980 minus 660, that's going to be 1,320. Okay, likewise 2,420 minus 440 is 1,980, and 1,760 minus 220 is 1,540. Okay. So based on this, we can draw the cash flow diagram. And starting from year 0, 1, 2, 3, and 4. At the end of period 0, there is a negative cash flow of 4,400. So 4,400. At the end of period 1, we have 220. At the end of period 2, 1,320. At the end of period 3, 1,980. At the end of period 4, 1,540. Right? And the interest rate we are going to use is 6%. Okay? So this is the problem 5-12. And in chapter 5, we've discussed about the NPW. What is that? Net present worth criterion. Right? NPW, which is the abbreviation of net present worth. Okay? That is, we compare two alternatives and select the one which provides the in which the present worth of benefits minus the present worth of cost is a maximum. Okay? So basically the net present worth can be obtained by present worth of benefits minus present worth of cost. Okay? So based on this cash flow diagram, can you compute the net present worth like this way? Present worth of benefits minus present worth of costs. So what is that? The benefits are the summation of this, right? And cost is 4,400. So the first benefit at the end of period 1 can be converted to the equivalent present sum, right? So 220 times P given F, right? 6% over 1 period. And then 1320 P given F, 6% over 2 periods. Plus 1980 P given F, 6% over 3 periods, and 1540 P given F, 6% over 4 periods. So these are the present worth, net present, the present worth. So these are the present worth of benefit minus present worth of cost, which is simply 4,400, right? So if you calculate this, it's going to be your net present worth of his investment in the equipment. So let's get these 4 factor values. %, P given F over 1 period is 0.9434 and 0.8900, 0.8396, 0.7921. Okay. So how much is this? what is the net present worth of his investment. Okay, this is the negative value, negative $135.41. So what is your conclusion? Because the net present worth is negative value, so you should not purchase the equipment. Okay? Okay, next problem that we are going to solve is problem number 5-13. So, in a present worth analysis of certain equipment, one alternative has a net present worth of positive 420. Based on a 6-year analysis period, that equals the useful life of the alternative. A 10% interest rate was used in the computation. The alternative device is to be replaced at the end of the 6 years by an identical item with the same cost, benefits, and useful life. Based on a 10% interest rate, compute the net present worth of the alternative equipment for the 12-year analysis period. So we are working on problem number 5-13. Okay. So here a device has a net present worth of positive $420. So 420, positive 420. That is the net present worth, right? Based on a 6-year analysis period. So based on the next 6 years. Okay? And the alternative device here is to be replaced at the end of 6 years by an identical item with the same cost, benefits, useful life. So the replacement equipment will have the same net present worth of $420. So we have another $420, which will last for the next 6 years, right? 6 years. So this is the net present worth, right? And we are using 10% interest rate. So here, as we know, the replacement equipment will have the same net present worth of 420 as the original equipment, right? And the replacement equipment have a useful life of 6 years as well. So using the 10% interest rate, we are required to compute the net present worth of the alternative equipment for the 12-year analysis period. Okay? So how do you compute that? The net present worth for the next 12 years can be computed by 420 plus this 420 at the end of period 6. So what you need is to convert this 420 to the equivalent present sum of money, right? So 420 times P given F, 10% over 6 periods. Is that very simple? So what is this? This factor value 10%, P given F over 6 periods, 0.5645. So how much is that? Okay, this is going to be $657.09. $657.09. That is the answer for problem number 5-13. Okay. Okay. And next problem that we are going to solve is, how about problem 5-15? A machine cost $980,000 to purchase and will provide $200,000 a year in benefits. The company plans to use the machine for 13 years and then will sell the machine for scrap, receiving $20,000. The company interest rate is 12% should the machine be purchased. Okay, so this is the problem number 5-15. So according to the problem description, the first cost, P, is $980,000, right? And how much is the salvage value? Salvage value is $20,000. So that is the future value, right? 20,000. And what about the annual benefit? That is $200,000. Okay, so an annual benefit, so $200,000. And the interest rate is given as 12% over how many periods? Over 13 years. So these are all the information that we could collect based on this problem description. Okay? Now, let's get the net present worth. So this is the present value that will cost you $980,000. So I put negative, and then there is an annual benefits of $200,000. So plus 200,000 times P given A, 12% over 13 periods, right? And then what else? The salvage value, which is $20,000 times P given F, 12% over 13 periods, right? After 13 periods, 13 years. So let's get those vector values. 12% is given in our text, page number 614. P given A over 13 periods is 6.424. What about this? P given F, 0.2292. Okay, so how much is this? So this is the $309,384. So the net present worth is positive value. So I recommend to purchase the machine, right? Okay, and here's the next problem that you are going to solve, which is the small modification of end of chapter problem 5-21. So a new office building was constructed. A new office building was constructed 5 years ago by a consulting engineering firm. At that time, the firm obtained a bank loan for $100,000 with a 12% interest rate, compounded quarterly. The terms of the loan call for equal quarterly amounts to repay the loan for 10 years. The loan also allows for its prepayment at any time without penalty. As a result of internal changes in the firm, it is now proposed to refinance the loan through an insurance company. And the new loan would be for a 20-year term with an interest rate of 8% per year, compounded quarterly. The new equal quarterly payments would repay the loan in the 20-year periods. The insurance company requires the payment of a 5% loan initiation charge. Often described as a 5-point loan fee, which will be added to the new loan. Then we have two questions. Question A, what is the balance due on the original mortgage if 20 payments have been made in the last 5 years? And question B, what is the difference between the equal quarterly payments on the present bank loan and the proposed insurance company loan? Okay. So let's first work on part A. So let's draw the cash flow diagram based on the problem description. So we are solving problem number 5-21M. So our cash flow diagram will be based on this, right? Okay. So we have $100,000 at the end of period 0. And there is a quarterly payments, right? For the next 10 years. And there are 40 quarters in 10 years. So the last payment will be made at the end of 40 quarters, right? So 40 quarters. So A is the equal quarterly payments. Is that right? Okay. And what is the interest rate? Is 12% annual interest rate compounded quarterly. So 5 years ago, a firm obtained a bank loan for $100,000 with 12% annual interest rate compounded quarterly. Okay, which means the bank charges 3% quarterly, right? How'd you get 3% here? 12% divided by 4, because there are 4 quarters in a year. So bank will charge 3% quarterly. Is that right? So the quarterly payment on the loan would be A equals 100K times A given P, right? And 3% over 40 quarters, right? So how much is this? 3% A given P over 40 periods, which is 0.0433. Okay, so how much is that? That's going to be, no, we just simply multiply by 100,000. So it's going to be $4,330. Okay. And what is the question? The question A is, what is the balance due on the original mortgage? It asks the balance due on the original mortgage if 20 payments have been made in the last 5 years. So let's say here we have 20 and 21 and so on. Okay. So this question says these 20 payments, all these 20 payments have been made, okay? And we'd like to know the present sum, P, which is at the end of period 20. So let's say this is P, okay? At the end of period 20, the present sum of P, okay? So how do you calculate this value of P? This P value at the end of period 20 is this quarterly payments amount, $4,330 times P given A, 3% over how many periods? 20 periods, right? From 20 to 40. So how much is that? 3% P given A over 20 periods. That is 14.877. This is the 14.877. So how much is this? Okay, this is the $64,417. So this is the balance due on the original mortgage if 20 payments have been made in the last 5 years. Okay? So this is the part A. Now let's work on part B. So what is the difference between the equal quarterly payments on the present bank loan and the proposed insurance company loan? So we need this information about the new loan from the insurance company, right? So it is now proposed to refinance the loan. Currently, the balance due is how much? The balance due is $64,417 from Part A, right? However, the insurance company requires the payments of 5% loan initiation charge. Okay, so the current balance due is $64,417 from Part A. And there is a service charge of 5%, which is 0.05 times this amount of money, right? $64,417. So how much is that? that is going to be 3,221, maybe, something like that. Okay. So as a result, the amount of new loan is going to be original balance 64,417 plus the service charge 3,221, right? So how much is that? $67,638. Okay, so this is the amount of new loan. And the new loan is for a 20-year term with the interest rate of 8% per year, compounded quarterly. So the interest rate would be 2% quarterly, because 8% divided by 4, because there are 4 quarters in a year, which becomes 2% quarterly interest rate, right? And the interest periods would be that's going to be 80 quarters. Is that right? So the quarterly payments on the new loan would be this new balance, $67,638 times A given P, 2% over 80 quarters, right? So A given P, 2% over 80 periods is 0.0252. 0.0252. Okay? So how much is this? This is $1,704. Okay? And the question is, what is the difference between the equal quarterly payments on the present bank loan and the proposed insurance company loan? From the present bank loan, the equal quarterly payments is $4,330, right? So the difference in quarterly payments would be 4,330 minus this, right? $1,704. So how much is that? Is $2,626. Okay? So this is the answer. for part B. Okay, so I'm going to stop here for today, and we'll continue to solve the end of chapter 5 problems next time. Okay? Okay, thank you. I will see you later. Bye-bye.